Hello and welcome, my name is Ryan, I'm also known as RM2K Dev. In this video I want to talk about creating a fighting game kind of input system. Now before we get started, I first want to apologize for the audio quality. I'm a bit unwell this week, so the voice is a little bit strange sounding. And also, I wanted to do something a little different in this video. Today, I've got a plan that I've written down on paper for what this system is going to be, but I haven't spent that much time actually creating a demo version of it first. Normally, I create a demo version and then I'll create a tutorial based off of that demo version. But this week, what I want to do is I want to create this with you. In that way, any errors and issues that we come up with, you're going to be able to see kind of how we go around the issues and work around them to actually create a system, rather than just getting the sort of perfect example. Obviously, at the end of the video, there'll still be a downloadable file which you can take and download, import into GameMaker and have a look at the code as a whole. But in this tutorial today, we're going to go through just the whole process, I think, and I'll try and get it edited in such a way that it makes cohesive sense, if that makes sense. Anyway, so let's get started. So fighting game input. So what I'm thinking is we have a sort of up, down, left, and right, W, S, A, and D. We have kind of a attack and a kick button. I'm just going to go with, sort of classic NES controllers here. I might use N and M for that. So it'll be like kick and punch. Now, obviously, in a fighting game, if you press like up, down, left, left, kick, punch, you're going to get one type of move. Whereas if you press up, up, down, right, you're going to get another type of move. And that's the kind of input system that I want to create in this video. So to get started, what I think we'll do is we'll create an object. I'm going to call this obj_controller. Okay, now in our object controller, I'm going to add a create event. And I just want to add some strings in here of the type of move, and then also what that move actually means. So we'll just put some comments in here first. We'll just say up, up, down, down, kick, punch is going to be one type of move. Let's do another one. Let's do down, down, left, left, punch, punch. And I'll leave a comment in here just to say that this is going to be, I don't know, fireball punch. We'll just put something in there like that. And I'll put something in here just to say that this one here is just going to be like, I don't know, whirlwind attack. Obviously, kick and punch are going to be kick and punch, so we'll just add a K equals kick and a P equals punch, so they're the obvious ones. Now, we need to think of how are we actually going to process this input. What I'm thinking is we process the input, we add it to like a string, so we're building it up as we go along. So every button that's pressed gets added to a string with one of these letters. So up will be U, D will be, S will be, down will be D, kick will be K, punch will be P. We build up these strings, and if there hasn't been any input for a certain amount of time, then we'll go ahead and we'll call that a input chain. And if an input chain matches a character's sort of input definition, which is going to be one of these, then we know that we've created the attack. So let's create a variable. We'll call it input chain, and we'll set it empty for now. I'm also just going to let's put this description up here and just say init vars. There we go. Now let's also go and create a key up event, I think will be the one. Key up any. So that's going to be our code there. And let's just put in here handle input. Now what I think the key up any function is going to do is when any key is pressed, it's going to give us a trigger this event so we can detect what key was pressed. I also think there's a function that I think it's a keyboard last character. So we can use that to extract, I think, what the keyboard's character was, or we could do it the old-fashioned way and just do, if keyboard. Actually, can we do that in here? No, I don't think we can do that in here. Let's have a look at what last character returns. So, by the way, this is how I would normally program. So I would probably do something like show debug message, and I'd put like keyboard last key, something like that. Then I'd run the game, and I'd probably just press a bunch of keys, and I'll just see what pops up into the debug window. Now, obviously, nothing appears to be popping up in the debug window. That's because I have put this in a key pressed. I think it might need to be in a key pressed. Is there a global key pressed? Let's have a look. No, there's no global key. Key press should just detect any key, I think. sure it should. All right, let's have a look at the documentation. So I'll middle click on it just to see what comes up. And then what we can do is this. And it looks like the keyboard last key function should be working, but it doesn't appear to be working. Let's try wrap this in the string variable so we can turn it into a string just in case it's not a string. I probably should have checked what data type it was. Nothing's coming up. Ah, you know why? Because I'm an idiot. You got to put the object in the room. Sorry about that. So put the object in the room, then run the game. Now we can have a look what's coming up. So we've got these key codes here. These are obviously relating to what the key is. Now that we know what they are, let's go ahead and press, actually I'll clear the debug window and I'll run the game again. And I'll press each key one by one. Up, down, left, right, and then kick and punch. And then I'll close the game. And let's scroll back up in our debug window and we can take this string of text because we know what these are. Coming back to our controller, I'll put a little a series of comments in here. I'll just comment that out because now we know that these numbers actually relate to up, down, left, right, kick, and punch. Now what we can do is a switch case statement to determine what key was pressed. So we can do something like switch. We're going to switch on last keyboard character. I can't actually remember how you do a switch case statement in here. I think it's case 87 and then break. I think that's how the source works for GameMaker, the syntax. Just make sure it runs. If it does, then we're okay. Yep, so that's fine. So we know that 87 is up. Let's add a bunch more case statements. We're going to have 83, which is down. We'll have 65, which is left. We'll have 68, which is right. So now what I'm going to do is I'm just going to say show debug message, and I'll just put something in here that says up. So now we've translated from sort of input syntax into, they're actually ASCII key codes, but we've translated from the key code into an actual string of text now. So if we press those buttons again while we're running it, we should get proper messages, or we'll get nothing because I probably messed it up. What have I done wrong here? Let's just show debug message on here. Keyboard last character. Let's have a look. Let's see what we're getting. So if I press up, we should get because I used keyboard last character. It was not last character. Keyboard last key is the syntax I was looking for. Okay, so the switch case statement is keyboard last key. So now we should get these correct messages when you press buttons. You'll get the right letters. You'll get the right text with it. Again, I want to just say this is a different kind of format video. I know this is not usually what I'll do to create something that's a little bit janky like this. Normally I plan them a lot better, but I figured we'll do something a little different today. We'll go through the whole process together. So bear with me. We'll get there eventually. So anyway, so at the moment what we have is these case statements. They represent the selected button. Let's add two more. This is going to be for kick and punch. We know that those are 78 and 77 on the keys. So we'll just say kick and punch. We'll just clean up that W there. Right, so now what we have is the full set of input for our fighting game. Now, if we were using sprites in this, you would tie these events, obviously you'd tie up, down, left, and right to actual object movement. You could do that in the step event to say, if left is pressed, move left. However, since we're working with just the input side of the fighting system, we're just going to be trying to get like a pretty cohesive system for dealing with those kind of combination moves. So for now, I'm not going to bother with doing graphics and things like that. I just want to get this input system working. So we've split up our input now into all the different types of input that are possible. We have this variable called input chain. What I think we do is we add a character to the input chain. Then we start a timer. The timer is going to be the delay between key presses. So let's say input chain plus equals, and then we'll put a string like U. So up, so that's for up. We'll put a string for like down, so it'll be like D. Put a string for L, and I think you can see where I'm going with this at this point. As far as what I'm thinking for dealing with these inputs. So I'm just going to do a K and a P in this one over here. There we go. So now what we've got is the input chain will build up. I think what we'll do is we'll say that's the input chain. So that's the real-time input chain. But then I think what we need is a sort of stored input chain. So we'll have a store input chain, and we'll set that to blank. Because that way, when we've detected that there's no more key presses happening, we can shift the input from the real-time input chain into a stored input chain that we can then process against. So what I want to do is I want to add a draw event so that we can see it. I'm just going to say draw. I'm going to say draw text at position 10, 10, and I'm just going to put string input chain. I don't need to put the string function there, but I just put it there just in case we add numbers or whatever happens. It will just be a string always. Let's just run it and see what we've got when we press buttons. So now as I'm pressing these buttons, kick, kick, punch, 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 kick, kick. So I'm creating an input chain right now, and you can see it sort of typing up on the top of the screen there. So that's the input chain. That's what it's looking like. Now what I think we need to do is we've built the input chain up. At the end of a key press, we need to fire an alarm. We need to tell this alarm like, hey, a key was just pressed. So we'll say alarm 0, and we'll just say 5. We may need to adjust this timer. This is going to be the timer to detect if another key press is happening. Like, are we building a chain right now? So we'll say chain timer. Then I'll add an alarm. Alarm 0. And in this alarm, what I will say is, what are we actually going to say? We're going to say when this alarm fires, is that how it's going to work? Actually, let's set this here first of all to 30. All right. And then what we'll do in this alarm, we'll just say input chain equals blank. We'll blank it out for now. Because what I think will happen is we need to see whether or not repressing buttons is going to continue. If I let go, it goes away. So yeah, as I continue to press buttons, the alarm doesn't fire, because before the alarm fires, we reset its timer back to 30. So if I keep pressing buttons, it will never clear. But if I stop pressing buttons, it clears itself. Now, obviously, the timing there is a little bit too slow, but I just wanted to confirm whether that function would actually work. So let's make it 10. Let's have a look what feels good. So I'm going to press up, up, down, down, left, right, kick, and see, I missed it. There we go. So I think that's a good timing. It's probably actually a little too slow. So let's set it maybe to 8. I'm going to go up, up, down, down, left, right, left, right, left, right. So that'll be our punch. I'm quite happy with that. That's a good timing, I think. We can do stuff like up, down, left, kick. Up, down, left, kick. Up, down, left, kick. Up, down, left, kick. Why am I getting 2 L's? Because last key pressed. That's okay. Up, down, left, kick. Up, down, right, punch. Up, down, right, punch. So these, I think, are going to be pretty good. Oh, sorry, I'm just testing it there. I think that's good timing. So basically what's happening is we're building up these chains of actions, then this alarm fires. So in here, I'm just going to say, I'll change the description to draw text on screen. And then over here, I'm going to say process attacks. Now, what I really wanted to do in this video was to, because like in games like Street Fighter and King of Fighters and things like that, you have this idea of attacks that are, what's the word I'm looking for? You can create an attack, but you can't interrupt it sometimes. So what I think we'll do is we'll actually create a dictionary of key values, and the value will determine whether or not the attack is, what's the word I'm looking for? Sorry, interruptible. So I think we might need 2 dictionaries. The first dictionary we need is the attack combination to a friendly string to determine what is the actual attack, and the second dictionary I think we need is whether or not it's interruptible. So let's create 2 DS somethings. I don't know what they're going to be yet. Let's have a look. We need to have attacks equals DS. Let's have a look what we have. I think it's a DS map. DS map create. So we're going to create a DS map for attacks, and we're going to create a DS map to determine if the attack is, what was the word I just used? interruptible. We'll just call it interrupt. So now we have two maps. So then what we're going to do is going to say ds map add, and it's key value. So now we can look up by key value. So I'm going to add, first of all, to attacks, I'm going to add the key, which is going to be the input string, which is up, up, down, down, kick, punch. And the value is going to be fireball punch. Then what I'm going to do is I'm going to do the, I'm going to do the same thing, but this time it's going to be for interrupt. Now, the fireball punch is an attack that is not interruptible. So what I'm going to do is I'm going to say false. So this way, we store information about the attack, its name, which is fireball punch, and whether or not it's interruptible. So it's not interruptible. So once you trigger this attack, you can't interrupt it. I'm going to add a couple more. I'm going to add the whirlwind kick, which is whirlwind attack. And this one, I'm going to say it is interruptible. Oh God, I can't spell today. Then I'm just going to do K for kick. Let's just do standard kick. This is interruptible. Let's make that K. And then P for punch. Let's just call this one here punch. And this is also interruptible. So fireball attack is the only attack right now that's not interruptible. So now that we have, actually, the other thing I'm going to do is I'm just going to put kick and punch first because that makes the most sense to have the basics at the top. So now what we need to do is, I think in the alarm we're going to process out the attack or the input string. So when the alarm fires, rather than just blanking out the input chain, we take the input chain, we stick it onto the stored input chain, then we look up in the DS map for the stored input. So this is kind of like last attack, basically, what it is. And in that way, the next time it fires, we can compare, it was the last attack something that was interruptible or not. So I think what we do is we just say, the first thing we'll do is we'll say input chain is blank. Then what we'll say store input chain equals, excuse me, actually, no, we'll do that last. So store input chain equals input chain. There we go. Then what we'll do is we'll say if store input chain, I think we need to do a string length function here. String length stored input chain is greater than 0. So if there's something in there, then we want to process the attack. So what we'll do, and we'll do it against the input chain variable first of all. So we'll look up against the attack. So we'll say ds map, I think it's find, what is it? That's the function I'm looking for. Read. Is it read? Let's try read. ds map read. Let's stop. Sorry, let's look up the documentation. So ds map read. No, I don't think that's the function. I can't actually honestly remember this stuff off the top of my head. Normally I look this up. Find value. That's the function there. Find value. So we're looking for a value by the key. So we're finding value. So ds map find value. ID and key. Well, the ID is going to be attacks. Is that what I called it? We called it attacks. Yes, we did. And the key that we're looking for is going to be the input chain. What am I doing that as a string for? Input chain. There we go. So this is going to return us the attack. The attack name is going to be equal to that. Then what we can do is we can say interruptable equals, we'll do the same thing, but this time we're going to look up for the interrupt. Actually, we don't look up the interruptible of the current attack. Actually, before we get ahead of ourselves, what I'm going to do is I'm actually just going to create another variable. I'm going to call this performing attack, and we'll just blank this one out. And we'll add another string to the draw function. This time we're going to draw this one here. We'll put performing attack, and we will put it at position Y 25. Now what should happen is we say performing attack equals attack name. Okay, so what that should actually do is now when we when we have a attack, we need to change this around. Sorry, we need to put this up here because we need to find an attack. We need to store this in here so that we have the attack. The attack is found, we store it in performing attack. Then we check if it is interruptible, because if it's not interruptible, we're not going to perform this attack. But for now, I'm just going to leave that there, but we're just going to use this to determine if we can pluck out the attack that we're looking for, and then draw it on the screen. So let's have a look at these. K and P are kick and punch. So if I press K, or I'm pressing the letters K and P. If I press K, we get kick. If I press P, we get punch. So kick, punch, kick, punch. Right, so that's working. If I press up, up, down, down, kick, punch, we should get fireball punch. So let's see if that works. Up, up, down, up, up, down, up, up, down, down, kick, punch. There we go. Up, up, down, down, kick, punch. You have to, you have to get the timing right, because if you don't, you're going to get the wrong attack. So there's fireball punch, and the other one was, what is S? S. What is S? Up, up, down, down, left, right. What is S? I put S in here for something. It's not supposed to be S. It's supposed to be D. So that should be DD. DD. Sorry. What am I doing? Down, down. Left, left. Down, down, left, left. So if we go down, down, left, left, and then punch, punch, we should get the whirlwind attack. I want to rerun the game just because that was messed up. Down, down, left, left, punch, punch. So that should be SSAAMM on my keyboard. There we go. So now we get the whirlwind attack. Right, so now we have the ability to select an attack. The real question, though, is can we get it so that it's able to interrupt another attack? So, for instance, if the next attack is not interruptible, then we don't want to actually do this performing attack thing. Alright, so if there was no... So what we need to do here is, if there was no previous attack, we do want to perform the attack, so we'll put performing attack there. If there is a stored input, as in the last input chain had something, then we're going to look up against the interrupt variable, interruptible equals, and then we're going to look up against, I think it was called interrupt, and this time we're going to look up the stored input chain because it was the last performed attack. Now, if that returned something, so if interruptible equals false, right, obviously we don't want to do anything, so do nothing. Now, my logic here makes no sense because what we really want to say is if interruptible is true, so we can actually just say if interruptible, then we're going to perform the attack. Else, we're going to show a debug message, show debug message that just says something like can't interrupt this attack. Wait until finished. Right? So now what should happen is we look up the attack, we check, was there an attack that had already happened, like, was there a last attack? If there was, check the last attack to see if it's interruptible. If it is interruptible, we're going to change to the attack that we're trying to perform right now. Otherwise, we're going to say, no, I'm sorry, you can't interrupt that attack. And then we're going to exit this sort of if statement. Now, if there was no previous attack, as in this is the first attack, then we always want to perform the attack. So I'm just going to say performing attack equals attack name. And I've made a mistake somewhere. I think I put a dot. Otherwise, then we're going to perform the attack. And then at the end of all of this, we're going to store the input chain that we input onto the stored input chain. And then we're going to clear out the actual input chain. So if we have a look at this, we do a kick. We're going to get a kick. We do a punch. We're going to get a punch. Now, those are interruptible. Definitely interruptible moves. But if we look over here and we have the fireball punch, which is not interruptible, up, up, down, down, kick, punch. Up, 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 down, down, kick, punch. Can't interrupt this attack. Wait until finished. Right, so now we have an issue. We have a slight bug. This kind of happens when you're coding, so let's have a look and see what we can figure out. So first thing I did is I did a kick. So that puts a kick into the input chain. Then if I do up, up, down, down, oops, put a kick. Do a kick. Right, do a punch, do a kick. Right, so if it's undefined, it looks like it's returning false. Right, that makes sense. So there's the bug right there. If the attack that looked up in this dictionary was undefined, as in we didn't find the key, then this becomes false. So let's have a look what this returns if it doesn't return anything. So it returns a real, a string, or undefined. So we actually need to check, first of all, is this undefined? Because if that's undefined, we still want to perform the attack, because we basically want to say that it's that it is interruptible if it doesn't exist. So we'll do something that just says if is undefined, I think the function is, if is undefined, interruptible, right? So first of all, if the interruptible variable is undefined, we're going to set it to be interruptible by default. So interruptible equals true. And I'll leave a comment in here just to say that if the lookup didn't work, default to interruptible, aka true. That way, when we look something up, if it doesn't exist in the database, it should still be interruptible. So now let's run the code again. Let's have a look and see if we can interrupt. So we'll do a kick, we'll do a kick, we'll do a punch, we got a punch. Now we'll do a fireball attack. Oops, I messed that up. Right, so I was able to perform a fireball punch even though the last move was undefined. Now, if I try and do a kick, I can't interrupt this attack. Oh, hang on. Alright, so we'll do a kick, and now if I do another kick, can't interrupt this attack, wait until finished. Then if we kick again, it's going to change. Now, the reason that that's changing is because, if anyone can guess, I'll leave you a moment. The reason that that's changing is... let me get back to the code here. The reason it's changing is because even though the attack was not interruptible, we still updated the input chain, the stored input chain. So we only want to update the stored input chain after we've actually performed an attack. So I'm going to shift that down into here and into here, and that way, if the attack was performed, we've updated the input chain, or the stored input chain, and that way when we look up next time, the stored input chain is going to show us the correct value for the last attack. Whereas what was happening before is it was updating every time. So even though the attack was not interruptible, I updated the input chain to say that the kick was the last attack, and then when we attacked again, well, a kick is interruptible, and therefore the fireball punch could be interrupted. So let's do a kick. We got a kick, let's do a punch, we got a punch, now let's do a fireball punch, there we go. Now if we try to do a kick, can't interrupt this, wait until finished. Now, we're never going to be able to get off this move because there is no interrupt timer. Now the next thing you could add, and I'm not going to add it in this, I'm just going to add a basic timer, but what you could do, if you really wanted to, you could add another variable here called timings. Right, I'm just going to show you how to do this. This is going to be homework if you want to have a go at it. You could add timings for kick, and you could add a alarm timing in here. So for instance, 60. That way, when you perform an attack, we'll start off an alarm, the alarm will count down, and once the alarm has counted down, we will clear off the input chain. And that way, the next attack will always be interruptible, and it will always work. But what I'm going to do as a basic kind of get us through the tutorial kind of thing, if an attack was performed, I want to start a timer. I'm going to say alarm 1 this time, and we're just going to set it to 60, for instance, right? And I'll do the same thing here as well, because anytime an attack was performed, we need to call this timer just to say that this is how long the animation is going to take. Then I'll add an alarm 1, and in alarm 1, what I'll do is I will erase or wipe out the stored input chain. So that way there is nothing in the stored input chain. So in alarm 1, we'll say stored input chain equals nothing. And we'll just put a thing in here, say clear input chain, and then we'll say, what was the variable I was using for the draw? Performing attack. We'll wipe out the performing attack as well. Performing attack equals nothing. So what should happen now is after a period of time, the attack should clear itself out. So if I do a kick, we'll get kick. A little bit of time later, kick will go away. So the kick is over now. If I do a punch, we'll get a punch. A little bit of time later, the punch will go away. Now if I do an up, up, down, down, kick, punch, we'll get a fireball punch. Now if I do a kick, uninterruptible, but then the kick's gone. Now I can perform a kick because the attack is over. Obviously, if you tied this to that timings array that I was talking about doing in here, what you would then do, instead of just adding a alarm equals 60, you would look up the amount of time that the attack takes to perform from the little database that we've created in our create event, and you would use that timing in this alarm here. And that's going to mean that however long your animation takes, now obviously you'll need to calculate how many frames your game is running at, what the update rate of your animation is, and tie the alarm time to the actual rate of animation. The other thing you could actually do as well, if you were doing this with sprites, is put your animation here. You could say like sprite, index equals, animated kick or whatever it is, right? Trigger the animation, and then instead of using alarm 1, like I was using here, alarm timers, you could actually use the animation end function. There's an animation end function right here. So when the animation is over, you could, swap back to idle and also clear the input attacks. Something basic like that, but, we're not using animations here for this kind of simple tutorial, but you get the idea. So anyway, I hope that was fun. I hope that made sense. It was a little bit back and forth. Again, I apologize for that, just because I didn't spend as much time planning this tutorial as I normally would, because I've been basically sleeping, because I'm a little bit sick, as you can probably hear. But it's a different approach to the way that we go about this. You get to see the bugs, you get to see what's coming up, rather than just getting a perfect code, a perfect product, and just following along word for word. I think it's actually helpful for some people to see the mistakes that are being made, so that you can see how we correct them, and see in your own games when you're working, what happens when you come up against an error like this? What kind of debugging steps do I take to get past an issue like this, or like that? And I think that's a kind of valuable tool for someone who's beginning, at least. Maybe not for the highly skilled members of the audience, but for people who are beginning, I think it makes a bit of sense to see that. Anyway, I'm rambling, but thank you guys for watching. I hope you've enjoyed the video. Again, apologies for kind of the presentation in this one, but we did get there in the end, and I will see you guys probably next week. Maybe a live stream over the weekend or something like that, but we'll see how we go. Thank you for watching. Take care for now, and I will see you guys next time.